everybody who is watching this video. My name is Olenjolai&Nekiny from the beautiful and fantastic country that called United Republic of Tanzania in Eastern Africa. I would like to welcome you into our fantastic YouTube channel that called it Tanzania Online O-Level Safety Schools. In square bracket you find Olenjolai. So I would like just to welcome you into these fantastic sessions for the basic mathematics, because in this YouTube channel we are teaching 3 subjects: basic mathematics, basic chemistry, and even also basic physics by using the syllabus of United Republic of Tanzania. I'm very happy to be a part of your academics, and today that we have as I said, that this is basic mathematics, so it showed that basic maths. And then the class is for the form series. This content for the form series, and this is chapter 5. It is called sequences and series. And the concept that I'm going to teach you in this lecture 2 is called the sequences. This is lecture or session 2. So let us go directly into the lecture contents. In case that this is the second lecture, it means that in this YouTube channel also you find lecture 1A and lecture 1B, or we call it session 1A and session 1B. So you have to make sure that if you didn't watch them, you have to watch them, because those 2 lectures, or those 2 parts of the lectures, the first lecture, that lecture or session, the first session explains all about introductions and everything that you have to know and you have to cover according to the syllabus. So let's just to do a quick review of what I taught you, or what I've introduced to you in the first lecture. So this we call it a quick review. Okay, so a quick review of lecture of session 1. So in session 1, first of all, I introduced you. I've introduced to you problems or introductions of the vision of this channel, and also I spent some few minutes to introduce to you about reference books, reference books and materials, useful and materials useful for basic mathematics. And also in this part, example of some of the reference books, I insisted you to have a syllabus according to your country. For if you are living in Tanzania, it's better to have a syllabus that's been designed by the Tanzania Institute of Education. And also I've taken you inside the syllabus of United Republic of Tanzania, and that syllabus is called the syllabus. It means syllabus of basic mathematics for secondary education in United Republic of Tanzania, prepared by the Tanzania Institute of Education. So also I've taught you, I've introduced it to you, and I mentioned to you about subtopics of sequence and series. So we form some of the subtopics according to the syllabus, and also I've introduced to you the specific objectives, and I left you some of them that I insisted you to make sure that you have these books, or the syllabus books, specific objectives in each subtopics. And also I've introduced to you contents that we are going to cover. Okay, contents of sequence and series means after reviewing the syllabus, then I developed the contents. It means that I broke down every concept that I broke down into the small slices so you can go through. And we had 5.1 up to 5.12, where the last contents, or the last subtopics, just so you can call it, the last concept is problem solving. Okay, and then I told you that this topic also is very important for engineers, and it's very important in daily human life. So you have to make sure that you go through the session 1 before you come to the session 2. So today in session 2, I'm going to teach you about sequences. And then in the sequences, I would like just to make a little bit introduction. Yes, a little bit introduction. So we can just say the sequences. That's today's lecture, say sequence. So plural is called the sequences. And the fundamental question that we have in this part possibly might call it question 1. What is sequence? Or when somebody asks you define sequence, how do you define sequence? Define sequence in mathematics, because you can define sequence in some other field. Okay, in mathematics or in maths. So I found 2 definitions of sequence. Okay, the first one is this one, that we say that in maths, okay, a sequence in maths, a sequence is an orderly listing, of numbers. An ordered listing of numbers. Okay, of numbers or other elements. Or other elements. It's not necessary to be numbers. Or other elements like geometric objects. Geometric objects that often follow a specific pattern or function, or a specific pattern or function. Okay. An orderly list, so it's order, right, of other elements like geometric objects, different objects such as tables. And then we say that often follow a specific, we call it a specific pattern or function. Means that a sequence has a specific patterns. It must follow specific patterns in order to simplify notation. Or some of the references define sequence in this way. Is a set sequence is a set of the set of terms, okay, the set of terms written, so the set in a definite order. Okay, to form a simple pattern. So I say that this is, he said that the sequence is a set of terms. I will tell you later in this lecture what the means of the term. It's a set of terms written in definite order to form a simple pattern. So whenever we are writing any sequence or any series, but here we are discussing about sequence, we should expect that we are following it means we are forming a certain simple pattern. It means a certain order, whether we are increasing numbers in ascending order, or whether we are decreasing numbers in descending order, or maybe we have a sequence of multiple numbers. So I will give you some of the examples. So we say that it is a sequence of an ordered list. So it means that the list should be in order, or order of numbers or objects, or for example that in number of students and etc. And then it means that it should follow a specific patterns or function. Or we say that the set of terms written in definite order to form a simple pattern, right? Form a simple pattern. So these are what I have underlined in these 2 definitions. We call them in mathematics keywords, because you should not only know how to solve some problems or mathematical problems, you should know also what the meanings of what you are solving by. Okay? So I have found some of examples. So you say that examples of sequences. So I would like just to give you some of examples examples of sequences are, so the first example, for example, we can have a set of natural numbers. We know that we have natural numbers, we have whole numbers, we have counting numbers. You know them during the 4 months you have learned them. So a set of natural numbers, we say that for instance, natural numbers always start from 1, then we go to 2, we have 3, we have 4, we have 5, we have 6, and then maybe this is infinite sequence. It does not have ends, it's continuing. Also, the second example of sequence can have a set of 40, can have a set of even numbers. So when we have been teaching you numbers, the topic of numbers in Form 1, okay? We taught you about even numbers, we taught you about odd numbers, we taught you about prime numbers. So you can have a set of even numbers. So we are using, I've decided to find examples of sequence which are familiar to you, so that you can understand the concept. Okay, so for example, a set of even numbers, we can start from 2, then the next one is 4, then the next one is 6, the next one is 8, the next one is 10, and then 12. And then start it might be the end of 40 of the sequence. Also, we can have a set of 40, can have a set of odd number. I believe that you know what the meanings of odd number, and they have used them in different cases. So odd numbers. And it's not necessary for to start from number 1. We can have a set of odd numbers greater than 10. For example, 11. Then you have the next one to be 13. The next odd number will be 15. The next one will be 17. And then the next one will be 19. The next one is possibly up to the odd number greater than 10 but less than 20. So then if it is one of the type, then you have 3 dots. Also, we can have a set of 40, a set of numbers that are multiples, of 40 or 5. So for instance, for this one, we can have a set of a sequence of numbers that is multiples of 5. You can start from 5, the next one is 10, the next one, tell me, 15, next one, 20, next, 25, and then next, possibly 30. Okay, so those are some examples of 40 of sequence. Again, we can have maybe a sequence of what? Sequence of fraction number. So we have a set of fractional numbers, or rational numbers, we call them fractional numbers. So you can have a set of, let's say, a fractions that 1/2, and then the next one 1/3, then the next one 1/4, then the next one 1/5, then the next one 1/60. Maybe this is finite sequence. So all of these are examples of sequences. It means that one term, so this 2, 3, 4, 5, 6, 4, 8, 10, 12, we call them in mathematics terms. So in sequence, the terms are separated by comma, while in series, the terms are separated by what? Basic operation, whether additions or subtractions or multiplications, and even sometimes division. Okay, so that's how we used to differentiate a sequence and series. In the next lecture also I'll teach about series, and we'll know the difference between sequence and series. In case that you have any question when we'll be learning these contents, please don't hesitate yourself to ask in the comment section. Okay, ask your questions as well as you can. Yes, I'll try my level best and even to answer your questions. Again, another thing, when we examine this sequence of numbers 2, 4, 6, 8, 10, 12, then we find that the next questions you have to ask yourself as a good mathematicians, you have to ask yourself, what are these numbers? How do we call them? These 2, 4, 6, how do we call them in general? So this one, we call them terms. Call them terms, say terms. So that's what I want to teach you right now. Terms of sequence and in series. We don't mean about terms and conditions, but terms of sequence, in short, and the series, in short, right? So he said that every member of particular party of sequence is called a term. Every member of a particular of sequence or series is called the term. So it's called your term. Each term has particular position value. Again, another thing you have to know that each term, say each term has a particular, each term has a particular, each term has a particular, each term has a particular value. Each term has a particular, value. Each term of a sequence or series, so we say that each term of a sequence or series, so we say that each term of the sequence or series has a particular value. So each term has a particular value. Each term of the sequence has a particular value. So for example, this one, we call it the first term, second term, third term, fourth term, fifth term, sixth terms. So these are the terms. This is the term, this is the term, this is the term, this is the term. This is the term, this is the term, this is the term, this is the term, this is the term. Right? So these are the terms of 40 of the sequence. And then, okay. So if that's the case, we say that each term has a particularity of the sequence or series, has a particular value. What does it mean? This means that, for instance, in the sequence of what? In the sequence of 6, let's say 8, let's say 10, then we have 12, we have 14, and then let's say it's the end. So this is the term. So all of these are the terms. So 6, 8, 10, 12, and 14. These in maths, we call them terms in total. But now, what the difference? Mean that is there any, for this 6 to be here and 14 to be there, is there any meaning in mathematics? Yes, because the positions of 16 is not equal to the positions of 14. So for example, we say that 6 stands in the terms that we call the first term. So 6 is first term. Then 8, this is turns in positions of second term. Then 10, this is turns in the positions of third term. And then 12, this is turns in the positions of 40 of fourth term. Fourth term. Then 14 turns in the positions of the fifth term, etc., etc. So regardless of how many terms that you have. So that's how we call it. So for example, this is 10 in the first terms, in positions of first term. And this is second term. And this is third term. And this is fourth term. And this is fifth term. So that the truth. Okay? So that's how we call them, or we call the terms. Okay, so good. So if you have any questions, please ask in the comment section. And I'll try my level best to answer your questions in order for you to understand what I've been teaching. So, again, we have a special name. So we have a special term that we call them in sequence and series. We call the general term or the nth term. So now I would like to teach you terms that we call the general, or we call the nth term. Say it, general or nth term. So the question is what the meanings of general or the nth term. So you say that the nth term of a sequence, nth term of the sequence or series corresponds to the last term. Corresponds to the last term of the sequence. So corresponds to the last term. To the last term. Corresponds to the last term of the sequence or series. So what does it mean? For instance, the 50th term for this sequence, for the sequence from 60 to 14, this one we call the nth term. Because 14, it's the last term. We call it the nth term. In this case, 8, this is equal to the nth term. Because the last term of this sequence. While 10, we call it the first term. Later on, so we'll be teaching about progressions, where we have arithmetic and geometric progressions. We have a special notation that we call them, or we notate these terms. So you have to be familiar. I'm still building the foundations in your mind. Okay, so that's all about the nth term. In case you have any questions about the nth terms, ask your general terms, ask in the comment sections, and then I will help you. Right? So that's the meanings of what of the nth term. So again, another thing that I have to teach you. Do you love mathematics? Please tell me in the comment sections. Types of what? Of sequences. Types of sequences. Types of sequences and what? And series. Types of sequences and series. No, excuse me. Types of sequences. Types of sequence. In maths, because you have sequences in music, you see. In maths, there are two types. There are two types of sequence, of sequences that are, the first one, we call it a finite sequence. Similarly to the series also, we have finite and infinite series, but for this case we have finite sequence and infinite sequence. But let us start with finite sequence. What is finite sequence? Okay? So that the questions. What is finite sequence? So the question is, what is finite sequence? That's the second question. What is finite sequence? What is finite sequence? Okay? Finite sequence, we say that is a sequence that contains the lasting, the definite, the lasting term, the definite or the definite lasting term of the sequence. That's the question that we have. So it's a sequence that contains the definite lasting terms of the sequence. So let me give you some examples. Okay? So you are warmly welcome into session 2. My name is Olenjolai&Nekiny. So welcome to enjoy the beauty of basic mathematics. Examples of finite sequence. Finite sequence are the first one. Case that we have 3, we have 6, we have 9, we have 12, we have 15. That's the first example. Second example, in case that, let's say we have 1/4, and then say 1/8, then say 1/16, then say 1/32, then say 1/64. So this is defined because the last term here is 15, and the last terms in this sequence is 1/64. But sometimes sequence, it may be in decimal numbers. For example, that we say that we have 0.5, and then the next one, we say that 0.5, next one we have 1.0, next one we have 1.5, next terms is 2.0, next terms is 3.5. So see, this is still finite sequence because the last term here is 3.5 and last term here is 1/64. The last term there is 15. Right? Okay, good. So that's all about finite sequence. So the only thing is it contains the finite or exactly lasting term. So the last term for the finite sequence is known. And hence you have the second type of the sequence. This we call it infinite sequence. So say infinite sequence. Say infinite sequence. So infinite sequence, we say that, what does it mean? What is infinite sequence? So infinite sequence, we say that is a sequence. So this is a sequence. The sequence which does not contain, or which contain infinite lasting term. Okay, infinite lasting term. So it's say infinite lasting terms, it means that undefined lasting term. Or we say that in lasting term, or we say that contains which does not contain, or we say that is a sequence, in other words, a sequence that does not contain the last term. In simple words, we say like that. Let us see some examples. Example, in case that you have a sequence of, let's say that you have a sequence of -4, and then -8, then -12, hence you have -16, hence you have dot, dot, dot. So it is still continuing. This is first term, second term, third term, fourth term, but there is no, the last terms is not known because the sequence does not have end. That means of infinite, does not have end. Okay? So the second example of infinite sequence, you can have infinite sequence of 1/5, 1/10, 1/15, 1/20, and then comma, dash, dash. So the last term also in this sequence is not known, the sequence of fractional numbers. Okay? And then, let's say the example, you might have that a sequence of whole numbers, but maybe you can have a sequence of 50s. So 50, comma 100, and then comma 150, and then you find that you have dot dot. So the sequence does not have the end. Okay? So that's the meaning of infinite sequence. However, that in this subject or in this topic, we'll be discussing a lot about finite sequence. Okay? Finite sequence. It means the sequence which have the last term in most cases. However, that in some cases, we might be learning the sequences, the infinite sequences. So then, after teaching you the concept from the beginnings of this lecture up this moment, I would like just to give you the first example. So this is example 1 in sequence. So the question asks you, what number patterns are obtained from the following description. From the following description. The following descriptions. What are the number patterns are obtained from the following descriptions? Roman R, so we have 3 Romans. Multiples of 3. Multiples of 3 less than 20. And then B, squares of counting numbers. Squares of counting numbers. This question I took it from one of the reference material or reference book. Squares of counting numbers less than 100. Less than 100. Then C, we say that counting numbers less than 50. Less than 50, but these counting numbers, but divisible by 9. divisible by 9. So that's the question that we have on the spot. What number patterns are obtained from the following descriptions? Let us read the question carefully. Listen carefully. Pause. Stop writing. Listen carefully. What number patterns? So the question asking about number patterns are obtained from the following descriptions. Roman A, multiples of 3 but less than 20. And then Roman B, squares of counting numbers. You should know the counting number, but they should be less than, the conditions they should be less than 100, because you have millions of squares of the counting number. Even here we have millions of the multiples of 3, but the conditions, they should be less than 20. Then C, counting numbers less than 50 but divisible by 9. So you should know the counting numbers which are less than 50, that's the first condition, but those counting numbers, you should not take any of them. They should be multiples of 40 of 9. So let us solve the problem. Solution. So we'll be solving each part separately. We study so many multiples of 3 less than what? Less than 20. So we say that we are looking for the number patterns. Multiples of 3, 3 is multiple of 3 by 1, because if you take 3 times 1, you get 3. Also, if you take another number which is multiple of 3 is 6, because 3 times 6 you get 3 times 2 you get 6. And the next one is 9, because 3 times 3 you get 9. The next multiple of 3 is what is 12, because 3 times 4 you get 12. And then the next multiple of 3 is 15. And the next multiple of 3 is 18, because if you take 3 times 6 you get 18. And then the next one, the next multiple of 3 is 21. But 21 already is greater than 20. So the conditions is from 3 to 18. So therefore we say that the number pattern in a particular pattern, okay, the number pattern is 3, 6, 9, 12, 15, and 18. But the number pattern. So this is the response. So let us go to part C. Part B, sorry, I'll give you the homework. At the end of this lecture, squares of counting numbers. What are the counting numbers? All that the counting numbers start from 1 and then goes to the big, very large number. Okay? So countings of 4 means the squares of the counting numbers less than 100. So squares. So when you say squares of the counting numbers, so we say that squares of counting numbers, squares of counting numbers less than 100. This means that if you square a certain number, you get a certain number. If you square 2, you get 4. So it means that the answer after you square some numbers should be less than, means the answer, it means that maybe the result, the last number, it should not exceed, the last square of the number, or the counting number, should not be greater than 100. So we start. What do we get if you take 1 square? So if you take 1 square, we get 1. What do you get if you take 2 square? Because 2 is another counting number, we get 4. What do you get if you take 3 square? If you get 3 square, you get 9. What do you get if you take 4 square? So if you take 4 square, you get 16. What do you get if you take 5 square? So if we take 5 square, we get 25. What do you get if you take 6 square? So we get 36. What do you get if you take 7 square? So you get 49. What do you get if you take 8 square? So you get 64. 64 still less than 100. What do you get if you take 9 square? So this will make 81. but a 1 still less than 100. What do you get after you get it 10 square? So it means that you will get 100. So this one will not be excluded because it's already equal to 100. And the question says that less than 100 should not exceed. So then now the squares are the numbers, are the answers after squaring from 1 to 81. So the last square is 81. Last square is 81. In case that you find going fastly with more than your speed of understanding, you can repeat this video several times as well as you can. Also you can pause. So therefore we say that the number pattern is 1, then second 2, become 4, then 9, then 16, then 25, then 36, then 49, then 64, and the last one is 81. So because this is the sequence, so you have to keep writing comma and make it separate the terms by using the comma. So that's the response for Roman B. Then you have again Roman C. So Roman C, counting numbers less than 50 but divisible by 9. Means you have to think numbers which are divisible by 9, but they should be less than 50. So we say that numbers divisible by 9 are, so number divisible by 9, first of all, the first number that divisible by 9 is 9 itself. 9 over 9 you get to 1. The second divisible number by 9 is 18, because 18 divided by 9 you get 2. The next number that divisible by 9 is 27, because if you take 27 over 9 you get 3. Then again the next number after 27 will be 36, because if you take 36 you divide by 9 you get 4. The next number will be 45, because if you take 45 over 9 you get 5. Again the next number is 54. Okay, so it's a divisible, because if you take 54 over 9 you get 6, but this is already greater than 50, so you've exceeded the condition. So we say that for this case, the number pattern is, or the sequence is 9, 18, 27, 36, and 45. And the end of solution of example 1. Okay, so in case you have any question, don't hesitate yourself, ask in the comment section. Well, so if that's the case, you say that the terms of a sequence can be extended if the pattern governing the given terms can be formed. These terms, for example here, the next terms can be determined. Okay, the terms of the sequence, can be extended if the governing if the pattern governing the given terms can be formed. If the pattern if the pattern governing the given terms is or can be formed. So the terms of the sequence can be extended, maybe from 3 terms into 7 terms, if the patterns governing the given terms can be formed. We'll do some examples on learning this concept. What does it mean? If you have, for example, if here you'll be given a sequence of 1, 2, 3, 4, 5, 6. So these are the 6 terms which have been arranged in a particular pattern. And then we can determine the next term by using a certain pattern. Dating this sequence from 16 to 81. So you can determine the next terms after 81, the next terms, and then the next terms, the next is second terms after 81, the next is third terms after 81, the third 80 terms, the first 80 terms after the 81. That's the meanings of this sentence. The pattern can be discovered by examining to see between these terms is 1. So let me explain in brief what are the explanations. We say the terms of the sequence can be extended if be formed. The rules. For example, these are the multiples. If you take these, okay, I'm still teaching you, tell you the concept of the sequence. Find the fifth terms of the sequence 1, 4, 1, 4, 7, 10. 7, 10 between the terms. So 10 plus 3, so the 50th term, for this case is what? 13. So the fifth term is what? Is 13. If you have any question, don't hesitate yourself to ask in the comment section. So the fifth term is 13, and that's the end of that. Fifth term is 13, and that's the end of that question. So let us go to the third example. Number 3. Given the sequence, and this example 3, you have to refer the book of Secondary Basic Mathematics by TAYai. Given the sequence 2, 4, 6, 8. Find the first term. Then B, the first term. First term. Then Ch, the nth term. Nth term. So we have Roman the first term, the nth term. So this one, try it yourself. Do it at homework. Solution. Given the sequence 2, 4, 6, and the 8, find the first term. The first term is already given in the sequence. So the first term, this is the first term. The first term is 2. No hassling. Then let us do for B. Yes, let us do for B. The first term, but okay, so this should remain as your homework. And then let me add D. We say that you find the fifth term. Find the fifth term. So let us go for D, and then we'll come to C, the fifth term. The sequence is 2, 4, 6, and D. And second term is 2. And the difference between the second terms and third terms is 2. And the difference between the third terms and the first term is 2. So even the difference between the first term, so let's say 6 terms, challenge you. So even here the difference is 2, so it will be 8 plus 2, and then the difference between the 5th term and the 6th terms will be 2, so 8 plus 2. So therefore we say that the 6th term of that sequence is what? Is 12. So we go for Roman C. Roman C, we say the nth term. The nth term, we say that we should identify it by using the particular patterns. And this is the pattern. The nth terms, you have to analyze the terms that the first term. So for example, if you take the first term 2 times 1, you get 2. Then if you take the second terms 2 times 2, you get 4, which is the second term. And then you take the third terms, which is 2 times 3, you get 6. And then you get 2 times 8 times 4, you get 8, that's the first term. And even the fifth term is 2 times 5, you get 10. And then the next term is 2 times 6, you get 12. So you continue, so you find 2 is common. So for example, the next term is 2 times 7, which is equal to 14. So 2 is common. And then you multiply by n is natural number, 1, 2, 3, 4, 5, 6. So because it does not have n, so you say that it will be n. So 2 times n. So the last term, is equal to 2 times n. 2 times n. So if that's the case, you say that therefore the nth term for that sequence is 2n. 2n. That's the nth term for that particular sequence. Again, we still have the last example for this session 4. In this example 4, we say that find the next 2 terms in each of the following sequence. Find the next 2 terms. Find the next 2 terms. Find the next 2 terms in each of the following sequence. In each of the following sequence. Each of the following sequences. So Roman R, you have 2, 5, 8, 11. 3 dots. B, you have 4, you have 2, you have 0, you have -2. This is your homework as the second question. Then you have Roman C, 1/3, 1/6, 1/12, 1/24. So that's the question. So when we solve, I left 2 questions for you to do as your homework. Of course, you have to test yourself if you've understood what I've been teaching you. Solution. So we have 2, 5, 8, 11. So we have to identify the rule which has been used to formulate the sequence. So for Roman A, you have a sequence of 2, 5, then 8, 11. So what the difference between 2 and 5? 3. What the difference between 5 and 8? Is also 3. What the difference between 8 and 11 is 3. So even the next term here, the difference between the next unknown term is 3. So for this case it will be 11 plus 3. And even the next term after this term, the difference between the fourth term and the fifth terms will be 3. So 11 plus 3 is equal to 14. And then 14 plus 3, so here it will be 14 plus 3. So the next two terms for that case will be 14 and 17. 14 and then 17. So therefore, the next two terms. Next two terms are 14 and 17 are the response for Roman A. Then for B, that's your homework. For C, we can do it together. It can help you because this fraction might be fractioned it at organs in fractions. So how can I do it? So this is 1 to 24. So regardless whether the sequence is in fractions or decimals, don't worry. The same rules will be used in, like in case of whole numbers or integers. So for this case, if you examine this sequence, it's a fraction. It has two parts. Numerator, denominator, numerator, denominator, numerator, denominator, numerator, denominator. If you examine, you find that numerator is a constant number, which is 1. And then if you examine denominator, it has been formed by following a particular rule. This is 3, this is 6, this is 12, this is 24. So it means that 6 has been obtained by taking 3 times 6, no, 3 times 2. 12 has been obtained by taking 6 times 2. And then even 24 has been obtained by taking 12 times 2. So what do we say? What the difference between them? So if you take that, if you examine, there's a rules that have been formulated that, for instance, for this case, you say that the second term, which is 1 over 6, this has been formulated by 1 over 3 times 1 over 2, right? Then the next term, the third term, which is 1 over 12, it has been formulated by taking 1 over 6, then multiplied by 1 over 2. And the next term is 1 over 24. This has been obtained by 1 over 12 times a half. So a half is common. So even the next term right now that we don't know, maybe call it term x, we'll take the first term, which is 1 over 12, 1 over 2. So the answer, 1 over 24 times 1 over 2 is 1 over 48. So that's the next term. Again, here we go. We take the fifth term, which is 1 over 48, we multiply by a half. So if you multiply, we get that 1 over 96. So the fifth term will be 1 over 48, and the sixth term will be 1 over 99. 96, not 99. 1 over 96. Right? So if that's the case now, if that's the case, you say that for Roman C, we say the next two terms. The next two terms are 1 over 48 and the 1 over 96. That's the response for that question. I left you 2 questions for the homework. Make sure that you do before this said session, and in the said session I'll be solving more examples or more questions concerning about the concept of the sequence, because I want you to understand the concept of the sequence before I teach you the concept of the series. So make sure that you go through this material and you revise them. In case you have any question, please ask in the comment section. Make sure that also you subscribe onto our YouTube channel that called Tanzania Schools in Square Bracket is Olenjolai. So for the YouTube community to give you notifications at any times when we upload a new video. So in case also you want to offer your Thanksgiving, please go to the descriptions of this video. You will find the 2 alternatives by using the bank accounts or by using the mobile transactions for Thanksgiving. If you want to offer the Thanksgiving to make sure that the more lectures of sequence and series or more lectures of birth mathematics you will be in air or will reach anywhere and at any times wherever that you are in the world. So thank you very much. I thank God for giving me this opportunity to teach you. Join me in the session 3 of sequence and series. Join me even in some other sessions of physics and even chemistry for all level or for ordinary secondary schools. And make sure that you invite your friends. You should take this material seriously, and then may God bless you, and make sure that you go through this material. May God bless you. See you in the next lecture.